The icy world, a space consisting of asteroids, their debris, and small objects, rests near the far reaches of the solar system. This is the Kuiper Belt. Kuiper Belt. This donut-shaped region, thick and round, expands beyond the orbit of Neptune. It is believed that the belt is a region of leftovers after the formation of the solar system. The Kuiper Belt inflamed scientists' minds for a very long time. The first significant achievement of modern technology that helped to study this cluster was the Pioneer 10 space probe, which was created to study Jupiter. Since then, about a dozen more spacecraft have passed through the Kuiper Belt. Even so, the place is still very poorly explored, and therefore new space missions are expected to be launched in the next decades. During the whole period of exploring the Kuiper Belt, many surprising bodies have been discovered: Sedna, Eris, Makemake, Quaoar, and many others. However, perhaps the most interesting and mysterious among them is the dwarf planet Haumea. It has a ring system, a tail, and even two small satellites. The first photos of Haumea appeared in 2003. Back then it was named 2003 EL61. Unaware of the existence of these photos, in 2004, just after Christmas, a group of astronomers, led by Mike Brown, discovered a celestial object about the size of Pluto. The astronomers named the object SANT. Another year later, while Mike Brown was preparing a report on the discovery of the celestial object, the same object, based on images from 2003, was studied by another team led by an astronomer, José Luis Ortiz Moreno. It turned out that two independent groups of astronomers wanted to claim the discovery of the object. Of course, it did not come to the real fight, although the plot is worthy of a detective novel, don't you think so? In short, it resulted in the International Astronomical Union classifying it as the fifth largest dwarf planet in the solar system. The object got a new name, given to it in honor of the Hawaiian goddess of fertility and procreation, Haumea. Even during the first observation of Haumea, scientists noticed that it flickers, getting brighter and dimmer by about 25% every 3 hours. It was thought that, if it is round, then this is related to its rotation. But according to calculations and our assumptions of the rotation of the planets and celestial bodies, it would simply disintegrate into pieces, because one rotation in 3 hours is extremely fast. Most likely, Haumea is greatly elongated, which makes it appear to us as if it flickers. Haumea is the fastest rotating object in our solar system. A true champion, it is far ahead of the nearest challenger, Jupiter, whose rotation around its axis takes 9 hours and 50 minutes. Most likely, it is the speed that causes its unusual shape. At the equator, it spreads heavily to the sides. That is why Haumea looks like a kind of rugby ball. However, it is still too early to dwell definitively on the shape of this dwarf planet. Because of many reasons, including the rapid rotation, scientists have never been able to figure out the inclination of Haumea's axis of rotation to its orbital plane. But it is certainly not round. The orbit of Haumea is moderately elongated, with a semi-major axis of 42.98 astronomical units. The longest distance from Haumea to the Sun is 51.47 astronomical units, and the shortest is 34.49 astronomical units. Today, Haumea is approaching the star, and the entire period in which Haumea completes one trip around the Sun is 281.8 years. Haumea will reach its closest point around the Sun, perihelion, in around 2133. The mass of the object is almost 32% of the mass of Pluto, and 24% of Eris. According to the latest data, the average diameter of the planet is 926 miles. Measurements of the mass and dimensions of Haumea indicate that the average density of this planet is 2.5 times that of water. And since the outer layers of Haumea are ice, we must assume that a rocky core hides inside this world. What is Haumea made of? In 2005, a detailed study of the spectrum of the object was carried out with the Gemini and Keck telescopes. Most of the dwarf planet is covered with a crystalline structure of water ice. Many features in the ice surface indicate the presence of cyanogen and kaolinite, which belong to the phyllosilicate minerals. Well, now you know the main properties and features of the dwarf planet Haumea. It's time to move on to the most fascinating part. The most essential mystery of Haumea was discovered in 2009. A color anomaly was discovered on the surface in the form of a rather large red area. This intriguing detail made scientists puzzled. They can't yet say exactly what this area consists of and how it appeared. But there are several grounded assumptions. This red spot may represent an area rich in certain minerals or organic compounds. It may be the area with a high proportion of crystalline ice. The main surface of this object should be old amorphous ice. It can also be a trace of a collision with another space body. What if it is an imprint of the very colossal impact that caused Haumea's deformed shape and such a quick rotation? In this case, the spot may be a mixture of the material of the impactor and, possibly, the exposed inner layers of the planet. It has been 10 years since the discovery of this area, but there are no definitive explanations of its origin. But, later, other amazing aspects of Haumea were discovered. In that case, another star came in handy. In January 2017, when Haumea was passing the distant star Urat 1,533,182,543, astronomers made observations of it using several European observatories at once. Particular features of the eclipse of the star allowed, first of all, to clarify the dimensions of Haumea. On the long axis of the ellipsoid, it is 1,443 miles, on the short axis it is 1,059 miles. This observation also helped to discover that Haumea has a ring system like Saturn. The ring is about 40 miles wide and is at a radius of 1,421 miles from the dwarf planet. It rotates 3 times slower than the elongated planet. There is a belief that the fast rotation of the dwarf planet was caused by a collision with some other object. According to this theory, this collision left some debris in orbit, which formed the ring. The discovered satellites, which orbit around Haumea, may be the confirmation of the theory about the collision. There are 2 of them. They were discovered right after the discovery of Haumea. In 2008, they were officially named after the goddess daughters, Hi'iaka and Namaka. Hi'iaka is about 193 miles in diameter and orbits Haumea nearly circularly every 49 days. The dimmer satellite Namaka is roughly 106 miles in diameter, and it orbits Haumea in 18 days in a moderately elliptical orbit. When asteroids have a similar composition, satellites, rings, and a tail of debris, they are called a collisional family. The Haumea family is the only identified collisional family in the Kuiper Belt. This is why it is so unique, because it is the whole system in the solar system. Of course, Haumea is the coolest object in the Kuiper Belt. Everyone wants to visit Haumea, scientists say. But the telescopes only won't be enough for further studying of Haumea. This world is so small that the only way to get to know its secrets is to go and explore it. If you ask our viewers, what is the largest planet in the solar system? Most would answer at once, without much thought, that it is Jupiter. And they would be absolutely right. But what about the dwarf planets? Which one is the largest? Well, I'm sure it will take some time to think about it, but still many will answer quickly and correctly. Pluto. But further, to name the second and third largest dwarf planets in our system would take much more time. Only a few people will be able to list, without the help of Wikipedia, at least a few candidates for dwarf planets, but in fact, there are many dwarf planet candidates, and one of the largest such objects, which aspires to try on this status, is Quaoar. No, it wasn't the slip of a tongue. Quaoar was discovered in 2002 by Mike Brown's famous group of astronomers. They discovered almost all the dwarf planets except Pluto and Ceres. Quaoar is some great force from the myths of the Tongva Indian people. So quasar has absolutely nothing to do with it. Why did they choose that particular name? The Palomar Observatory, where the object was first observed, is located in Southern California, in the territory of these people. Compared to other Kuiper Belt objects, Quaoar may not seem too remarkable. However, it is an important part of astronomical history. Quaoar was the first major object beyond Neptune's orbit that was discovered since Pluto. Its discovery foreshadowed the discovery in the next 3 years of Sedna, Orcus, Haumea, Eris, Makemake, and a number of other bodies. This in turn led to a number of important developments, including the revision of Pluto's status and the current search for Planet X. Quaoar is a trans-Neptunian object. These are celestial bodies that orbit the Sun and have an average distance to the star that is greater than Neptune's 38 U. Quaoar has a maximum distance to the Sun of 44 astronomical units, 44.896 to be exact. It takes 286 Earth years to complete a full rotation around the star and takes 17.7 days to complete one rotation around its axis, meaning that a day lasts 24 hours for us, but more than 400 hours for Quaoar. The calculated diameter of Quaoar is 780 miles, and the radius is 338 miles. The planetoid follows a nearly circular orbit, slightly inclined, but much more planetary than Pluto. Quaoar's orbit is unique among large objects, which usually follow more inclined and more eccentric orbits. Having a nearly circular orbit, Quaoar is not susceptible to disturbances caused by Neptune, unlike Pluto, which owes its orbit stability to Neptune. As for the composition of this object, everything is very uncertain. There is very little information, primarily because Quaoar itself is poorly studied. Nevertheless, thanks to its passage against the background of a distant star, a couple of years ago, it was possible to shed light on some mysteries of this celestial body. First of all, no traces of an eclipse were found on the starlight curve. It imposes both serious limitations on the size of Quaoar and rather strict upper limits on the density of its atmosphere. After that, an article on the possible atmosphere of Quaoar by a group of American astronomers appeared in the Electronic Preprints Archive. They considered three gases that could be part of the atmosphere: methane, carbon monoxide, and molecular nitrogen. At an average surface temperature of Quaoar, about -380 degrees Fahrenheit, gaseous nitrogen and carbon monoxide in balance with nitrogen and carbon monoxide frost on the surface should form an atmosphere with a pressure of about a few microbars. The presence of such an atmosphere would lead to a drop in the brightness of the background star, which was not observed. Thus, the paper's authors ruled out the nitrogen-carbon monoxide atmosphere of Quaoar. The situation with methane was even more complicated. Methane sublimates at a higher temperature than nitrogen and carbon monoxide, and the methane atmosphere, which is in balance with the methane ice on the surface, will have lower pressure. According to calculations, a methane atmosphere is possible at Quaoar. This conclusion is also confirmed by the spectral traces of methane ice on the surface of Quaoar. Finally, in 2007, a satellite of Quaoar was discovered. It rotates at a distance of 9,000 miles over a period of 12.5 days. It was named Weiwat, which, going back to the mythology of the Tongva people, is the son of Quaoar. The satellite has a significantly elongated orbit, and considering the unusually high density of the object, it could have been formed as a result of a collision of a proto-Quaoar with a more massive body. In this case, proto-Quaoar lost its icy mantle, retaining only its dense core, and the satellite was formed from the emissions from the collision. Why is Quaoar, with its sufficient mass and size, still only a candidate for dwarf planets? After all, it was discovered in 2002, even earlier than Haumea. Recall that any celestial body that orbits a star, with the necessary mass to be rounded by its own gravity, but insufficient to clear space around it, is considered a dwarf planet. The object's mass is also expected to help counteract the contraction and set it in hydrostatic balance. Quaoar has the right to be called a dwarf planet. It is a double object, with a density of 2.2 grams/cm3, and a suitable diameter. In general, all this proves that it is a full-fledged dwarf planet. In addition, its mass index for hydrostatic balance is higher than required. So what is the problem? To be honest, I haven't managed to find a coherent answer to this question. Perhaps it is still a candidate because it is very poorly studied and therefore astronomers doubt the parameters, size, and mass that we have at the moment. What do you think? Write your thoughts in the comments. By the way, researchers originally wanted to send New Horizons to Quaoar after the Pluto mission was completed, but NASA said that's impossible because the object is too far from the orbital path of the spacecraft. Today, There is only this image of Quasar from the New Horizons probe. For now, we just have to wait for new space missions that can study in detail not only Quasar but also many other objects in the Kuiper Belt. There are a huge number of star systems in the universe, and almost every one of them has at least one exoplanet. Every year scientists discover more and more distant worlds, and we get more and more surprised by their unusual features. Meanwhile, at the edge of the solar system, there are planets, which are more interesting. The edge of the system is the Kuiper Belt, a very mysterious and fascinating place. According to astronomers' estimates, there may be more than 200 candidates for dwarf planet status in the belt, but no one knows how many of them are there. It is said that this is where the planet that for some reason is called Nibiru and the Horseman of the Apocalypse hides. Of those actually discovered, here is the dwarf planet Haumea, which rotates around its axis very rapidly, making it very elongated. There's Eris, thanks to which another solar system object, Pluto, is demoted from the status of a planet. There's also Sedna in the Kuiper Belt. This is another dwarf planet with a year that lasts more than 10,000 Earth years. That's the one we're going to talk about today, Makemake. Let's see what amazing features it can boast. The first people to discover this planet were astronomers Michael E. Brown, David Rabinowitz, and Chad Trujillo. It was in the spring of 2005, during Easter, so they called it Easter Bunny. In the catalog of minor planets, the object was listed under the number 136,472. As many as 3 years it bore that name until in 2008. The planetoid was named after the creator of humanity and the god of fertility in the mythology of the natives of Easter Island, Makemake. It is still difficult to determine its exact size, but according to the calculations of the Spitzer Space Telescope, the diameter of the planet is 860,1000 miles, or 3/4 of the diameter of Pluto. That's large enough to place Makemake third among dwarf planets. The maximum distance to the Sun is almost 53 astronomical units, or 53 distances from Earth to our star, in case anyone has forgotten. Because of this enormous distance from the Sun, the surface of Makemake is terribly cold down to -407 degrees Fahrenheit. The dwarf planet's orbit is tilted to the ecliptic plane and moderately elongated, and Makemake's shape is a slightly flattened ball. Makemake takes 306 Earth years to make one trip around the Sun, and a day passes here in 7.5 hours. The mass of Makemake is estimated at 0.05% of the Earth's mass. The chemical composition is still being established, but something is already known. For example, on the surface of the planetoid, there is methane and ethane in the frozen state in the form of grains. There is very little nitrogen on Makemake, with a small amount contained in the methane ice. It is believed that the reserves of nitrogen have been depleted over the lifetime of the planet. Astronomers also believe there are thlins on the planet's surface, which make Makemake appear slightly reddish. Thlins are organic substances that are a mixture of different organic copolymers. These are substances whose chains of molecules consist of 2 or more structural units. Thlins are formed when ultraviolet light from the Sun interacts with ethane and methane. The most interesting thing on Makemake happens to the atmosphere. As the planetoid orbits the Sun, the grainy methane and ethane heat up and, under the influence of heat, change to their normal gaseous state. These gases then rise upward and surround the planetoid with an atmospheric layer. The methane-ethane atmosphere exists as long as Makemake is in such a favorable heat zone. When it begins to move away from the Sun, moving into the colder cosmic terrain, the methane and ethane freeze and crumble to the surface in snowflakes, taking the form of grains there. That's the kind of temporary atmosphere Makemake has. But that's not all. For a long time, since the discovery of this dwarf planet, scientists have conducted a series of attempts to find any moons around it, but all searches ended in failure. But in 2016, the search yielded long-awaited results. The discovered object was codenamed S/2015 or MK2. The task of finding the Moon turned out to be really difficult. For the most part, the special brightness characteristics of Makemake played a role there. Because most of Makemake is covered with a dense layer of methane ice, its reflectivity is 1,300 times greater than that of MK2. The brightness of the satellite is only 0.08% of the brightness of the planet itself. All this makes the tiny Moon very difficult to detect. Scientists were able to break through the brightness of the planet and find the Makemake's moon only by using the powerful optics of the Hubble Space Telescope. The diameter of the tiny satellite is only 100 miles, which is about 9 times smaller than the diameter of the dwarf planet itself. MK2 was seen approximately 13,000 miles from the dwarf planet. Initial observations indicate that MK2 has an orbital period of 12 days. To confirm this calculation, and to answer the question of how MK2 appeared in Makemake's orbit, several additional analyses of the Moon's trajectory and orbit will be needed. Confirmation of a cyclic orbit. According to preliminary data, the satellite has exactly a cyclic, that is, circular orbit, could indicate that at some point in its history, several billion years ago, for example, MK2 collided with Makemake and was attracted by the dwarf planet's gravitational pull into its current orbit. In its turn, the more elliptical orbit would suggest that MK2 was most likely attracted by the planet as it passed by it. This theory does not imply a direct collision. The presence of a moon could also explain previous observations of periodically increasing and decreasing infrared emissions from the planetoid, which were originally falsely assumed to have originated from warm spots on Makemake's surface. There is a suggestion that, unlike larger planetoids, the relatively weak gravitational force of MK2 was insufficient to keep methane in solid form, in the form of ice, throughout the Moon's surface. As a result, and under the influence of the Sun's rays, some of the ice on MK2 has melted. Thanks to the discovery of the MK2 Moon, it will be possible to calculate and determine the characteristics of Makemake, including the density and composition of this object, more accurately and in more detail. So, in the foreseeable future, we are waiting for fresh news from the dwarf planet with a beautiful and slightly funny name, Makemake. And to be among the first to know about them, subscribe to our channel and click the bell button. I'll see you in the next interesting videos.